Hi everyone, and thank you for joining us today. My name is Brian Russell. I'm the business line manager for V-Ray for Revit. I've got over 20 years in the AEC industry, most of them focused on my former life as a BIM manager and a Revit implementation specialist. I joined rejoined Chaos Group, I should say, about 2 years ago to help get the V-Ray for Revit product out the door. And I'm happy to announce that this year we finally released V-Ray for Revit into the wild. So quick agenda for today. I'm going to give you a brief product overview, chat just a bit about the simplified user interface if you're familiar with some of the other Chaos Group products. One of the things that we've heard kind of loud and clear from our customer base is that we need a simplified user interface and user interaction with the product, and so we've done that with V-Ray for Revit. We're going to touch on camera effects, the standalone VRMat Editor that ships with V-Ray for Revit, and we'll just briefly touch on Swarm, which is our new distributed rendering capability that's built into V-Ray for Revit. It will also be shipping with V-Ray for Rhino and V-Ray for SketchUp, which should come to us early in the new year, so be on the lookout for those as well. Many of my designers are familiar with creating this type of imagery, and many of the folks that I've spoke with over the years have said, look, when I'm designing in Revit specifically, I just need quick imagery. I need model in white imagery, which is what you're looking at on your screen here. It's not photoreal, it's actually non-photoreal, but it helps tell a story, and the story that we're trying to tell with this type of imagery, it's important to note, is that we're focused on form, space, light, things that matter to architects and designers, both for internal design validation as well as in presenting to the client without having them get hung up on materials. But we want to look at this. We also want to look at taking this a step further. And so this is an example of a 3D rendered, the exact same model. This is a 3D view from the Revit sample scene that everybody knows and either loves or hates, depending on how you look at it. We're using a subsurface scattering material, an SSS2 material here, to get a look of a 3D printed model. And one of the benefits to doing something like this is many firms are actually 3D printing models of their designs. And here you can do a rendering that matches that like starch-based 3D printed model, for instance, and take a series of images that match the actual physical model. It helps the client connect in a way that's really positive. So this is just an override material for us. We set up the SSS2 material properly. We assign it as an override material, and then we override anything that's transparent with a none material or with a plastic material, and it'll give you this same basic look. So fairly simple to produce this image and fairly quick to produce this image. And this is what you would typically expect from most of the designers that work in architecture firms today. I do want to take a moment to just touch on designer versus visualization expert, and I'm sure I've got both on the line now, but I do want to touch on how we've crafted V-Ray for Revit to be really focused on the designer level of imagery, but I do want to note that there are some tools that are available in V-Ray for Revit that will really help the visualization expert as well. So V-Ray for Revit was basically designed for designers to be able to do design validation, for them to be able to go in, do quick studies, and get imagery out that makes sense, and let the design or let the expert, design visualization expert, really focus on crafting a good image. And so I'm going to show you this image, which is created by a visualization specialist, and we'll come back to this here in just a little bit, and I'll do a step-by-step breakdown as to how some of this works and how some of this came about. This is V-Ray for Revit under the hood. For those of you who have not seen this slide before, these are some of the many thousands of settings that go into V-Ray behind the scenes. And for us to make a user interface that made sense for a lot of our designers, it was important for us to take these settings and turn them into something that meant something real to a designer. A designer's not going to take the time to learn what minimum or maximum subdivisions are, DMC's sampler thresholds, etc., right? And we don't want them to be focused on that. We want them to be focused on the design. So we've taken these settings, met with our top artists and designers throughout the world, and had them bake these settings, and the best settings for speed and accuracy, into draft, low, medium, high, and very high inside the ribbon, which is what you should be seeing here in the interface on the slide right now. So you see draft, low, medium, high, and very high. You simply select the version that you want. Draft is going to be very fast. It will have a little bit of noise to the image itself, but it will give you fast feedback for design validation. Very high is going to be closer to production level rendering and will allow you to kind of get out outside with into client presentations, things of that nature. We have some new camera tools that are built into V-Ray for Revit. What we've done is looked at things like exposure value, physical camera properties, and we've tried to make them as easy to use as possible. So I'm showing a video at the moment here where we're making small adjustments to exposure value. We've got it on a slider, and you're looking at RT rendering this, so it will update as we make adjustments to the exposure value. We'll get live updates in the scene. So if your lighting seems to be incorrect, you can simply drag your exposure value or type in your exposure value and have that adjust to give you a quick way to do the difference between an interior scene, which is going to have a much lower EV, versus an exterior scene, which will have a much higher exposure value. We've also got white balance controls in here and effects down here as well, which I'll touch on here in just a moment. And one other thing to note here is that the camera mode, we've got standard camera here, but in this drop-down we have a VR camera as well. So it's just a single preset now to do VR output directly from V-Ray for Revit. So also to add kind of a little more to design effects, camera depth of field effect is built in, and it's on a slider as well. So you simply set the target for your camera and you adjust the amount of depth of field effect, and that will come through for you so that you get nice camera effects directly in the V-Ray frame buffer. In addition to that, we've got one-click output to Cubic VR Imagery. This will allow you to go out to Google Cardboard, Samsung Gear VR, even Oculus, and the HTC Vive devices. So we are fully integrated into VR headsets. In the future, on our roadmap is finding a way to integrate RT into the mix, so you can actually have a VR headset on, rendering RT, making design changes and seeing them update in the VR headset in real time. So stay tuned for that in the future. That's on a roadmap, but we're moving in that direction. Should be interesting to see what we're able to do in that regard. With V-Ray for Revit, we had to be really careful how we treated materials. And so to that end, what we've done is really focused on being non-destructive to your BIM, because job number one is getting documentation and design completed. But also giving you the ability to get to a photoreal image that looks really good by doing material overrides. And so we now ship a standalone material editor, or VRMat Editor, if you will. And what you're seeing is the VRMat Editor, and I'll show this a little later in live demo, and as well as a material override map. Now we've got global material overrides that allow you to just override everything that's somewhat transparent with a transparent material, everything that's opaque with an opaque material, and it's just that easy. But you can also get really granular and override specific materials with VRMats that allow you to do things that Revit won't allow you to do specifically. And so things like grass with a displacement lends the look to 3D grass that actually has texture and depth without looking, that actually looks a little better than just using a bump map. And so displacement is supported in VRMat, and so we suggest that. Subsurface scattering, and some of the newer shaders that are available out there as well, like GGX shaders, will allow you to do metals in a very nice way, very impressive way, for long term. So be on the lookout for some of those. And we'll have tutorials available both through Microsol and through our website that get into specifics on each of these in a lot more detail than I'll go through today, but at least we can get you up and running today and making some imagery. This is V-Ray Swarm, and I'm going to go through these relatively quickly just because we're getting along fairly quick on time here. But what we have here with V-Ray Swarm is the ability to send distributed renders directly to the product. You can now manage your render nodes directly from any other render node. And as opposed to sending one VR scene package to each of the individual nodes, you send it to one, and behind the scenes it's using peer-to-peer networks to share that same scene between individual render nodes. So we have the ability to tag individual computers so that you can set up individual ports of interest to send your renders to. So if you want to do a GPU cluster, for instance, versus a CPU cluster, you can do that type of thing inside of Swarm directly. And of course, you can look at and manage CPU, GPU resources, memory, network, etc. on each of the individual nodes as well, so you can see how they're performing. Inside the product, I'll show you a little bit later, you can simply drag how much of the total network resources you want to use, and it's elastic, so your end users never notice that their computers are being used by the renderer itself. It's only using whatever they're not in terms of processing power. So elastic is the big word there. It's a really powerful tool, and I would suggest that each of you have a look at it when you have an opportunity. So here I am back to our original image, and what I'd like to do is kind of break this image down a little bit so that you understand behind the scenes what we've done to get here. We've done an override on the grass material with a snow material that has a texture. In this case, we're using both a snow texture that has bump map as well as a slight displacement to it. And this, by the way, is the sample scene that ships with Revit. And this is rendered almost completely wholly. There's one frame in here that's post-production, and that's the snow that you see kind of in the foreground falling from the sky, but everything else is rendered directly in V-Ray for Revit. We've bumped up the actual lights inside of V-Ray for Revit, or inside of V-Ray, or excuse me, inside of Revit specifically, because we're using Revit native lights, and so we've changed the lighting to be a little more orange, a little warmer. Of course, we're taking the lights that exist in your current model and we're translating those to IES files automatically behind the scenes. But one of the great things that you can do in V-Ray for Revit is that you can actually select on an individual light or light fixture and override the IES file, and we'll pull that through in the renderer itself. So as you make the change in your BIM, that updates in what we pull across. If you've got just a generic fixture in there and you haven't specified an IES light, we'll use the generic IES file. So important to note that, and what we've done is just made it a nice warm yellowy orange color, and so that warms up the interior view, and that's what you're seeing inside of the scene here. We've got standard V-Ray glass that we've applied to the glazing itself. One of the things that V-Ray does very, very well is glazing, and our architectural glass VRMat that ships with the product is what we're using here. RPC objects translate directly across, so the people that you see in the scene and the trees that you see in the scene are coming directly across from the sample file. We're using, in this case, an HDR imagery as our light, so we're using a dome light. And then that dome light is set to be a winter sky, low light condition, and it's I believe it's set at 15 is the intensity value that it's set at, and so that's basically effectively what we've done to get that kind of low light in the exterior and then nice bright lights in the interior using exposure value tweaks. And then finally we've rendered this thing in passes, and I'll show you how you can actually export individual parts of this frame out to Photoshop. The roof that you see there is again an override material that's rendered in this case in two passes. We've done a roof shingle and then we've done an override snow that's got some knockouts applied to it so that it appears as though snow is only placed in a few areas on the roof. So lots of little tweaking here and there. This image actually takes hours of compositing to put together, but with a little bit of effort you can get here fairly quickly, and it will give you some fantastic results that you can sit in front of a client. So the important thing to note as a final bit of realism here is that we've taken falling snow, and actually this was generated inside of Photoshop, and then we've applied a motion blur to that and set that over the final frame, and that way it sits right in front and gives the illusion of depth and snow to the scene, which just adds something a little extra to it. And it's through these types of tips and tricks that you can add a level of realism to your imagery. You can do similar things with raindrops, with puddles on the ground, again using advanced material techniques inside of the VRMat Editor. If you've got a visualization specialist, they may use V-Ray for 3ds Max. They can create V-Ray VRMats inside of 3D Max that you can actually use as override materials inside of V-Ray for Revit. Likewise, the same applies for V-Ray for Rhino and V-Ray for SketchUp. If you create materials in either one of those products, VRMat, you can bring those directly into V-Ray for Revit as well. And of course, you can use the standalone VRMat Editor to produce materials that will work for any one of those products as well. So this is the portion where we switch into live demo mode, and I always preface this by saying what could possibly go wrong? Well, when we're doing live demos with GoToWebinar, there's always the possibility that things could end up crashing or becoming problematic. So bear with me if it does. I'll come back to it. But for now, I'd like to at least show you a bit of the product and show you a little bit of what we've done in V-Ray for Revit specifically, and point out a handful of objects that are inside of the V-Ray for Revit interface that will allow you to get kind of next level imagery directly out of V-Ray for Revit. So over here in our renderer, we do have, this is the place where you would turn Swarm on and off inside of the renderer itself. We do have a project gallery, and the project gallery is going to save all of the imagery that you produce inside of your renders in a temp directory that you can pull up and see in the history here. So you do have the ability to go back to any of your renderings, whether they were in process or not. And this can be really valuable when it comes to compositing different images or to just finding out what were those settings when I did such and such a rendering. So you can refer back to the project gallery at any point in time. Quality levels, it's good to do low resolution draft renders while you're trying to set up your image. And I typically suggest that people do a model in white rendering, which I'll show you here in just a moment, to get their lighting right. And once the lighting is right and they're happy with the overall lighting, then they can work on tweaking individual materials by turning off the override materials and focusing on each of the individual settings. I'm happy to note that in 2017.1, when you are inside of a camera view, you can actually send a rendering now. That's something that we couldn't do before, but Autodesk has listened and opened up part of the API to us that they weren't able to before. So we're going to have a patch out soon that's going to take advantage of that in 2017.1. But if you have the existing release version of V-Ray for Revit, you can now send renderings directly from 3D views. For those who are in older versions of Revit, 2016 and 2015 for instance, you can still select your individual cameras directly from the project browser here. This is where we'll turn our interior lights on and off, and again, all we're doing is using what's in your BIM database. So make sure that your lights are correct. And one kind of tip, if you will, most of the light families that I've seen in Revit have an issue where the point light object itself is buried inside of the geometry. You'll want to make sure that you pull that light object down and outside of the geometry for it to show correctly. Pay close attention to your lighting families. even, and especially if you get them from manufacturers. Whether they're nested families or not, you'll need to make sure that you pull those light elements down to the bottom side of the geometry itself for the lights to work correctly. And then always look for a manufacturer's IEF file that matches your design intent. And then you can get really great results with interior lights that way. Resolution settings. For this particular demonstration, I'm just using crop region and printer. These are the settings that come kind of basically use what's in the image itself or what's in the camera itself. For our renderer, we've got the regular V-Ray renderer as well as RT. In this case, we'll be using the regular renderer for our purposes. I'm just going to kick off a quick rendering here. Bear with me just a moment as this kicks in. Again, because I'm projecting, things will run a little bit slower than they would ordinarily. We're using buckets for the pre-passes, and then it's kicking into progressive render mode. So what you're looking at here in this particular case is that we're taking the Autodesk materials that are assigned to the particular object, and we're simply doing a translation to VRMat behind the scenes. No frills here. In fact, the noise channel that you see here is a direct result of the concrete noise material that's in Autodesk and how it comes through the API. So we're pulling it across just exactly as it's been specified in the Autodesk material itself. So you do have the option of actually modifying the Autodesk material, and we'll make that change. Or you can allow this material to be overridden, excuse me, by a VRMat. So let me just go ahead and shut this rendering down for now. That's in draft mode, so you should be able to see that. We've got our exposure settings and camera settings here, but then we've got our material browser here. And our material browser is going to list everything that's in the project initially, but we can also filter for just current views. So current view is going to use from yard, and now we can see all of the individual materials that are in the from yard scene. So if I didn't like that concrete, I can go find that concrete and do an override with a specific V-Ray material. And again, I can come in here and find a specific material that I'm looking for. We do ship with a handful of materials with the product, so you can use those. Or I can drag and drop a VRMat directly on the scene here, and that will do an override as well. So big things to note: grass, typically we want to use a material that's got some type of displacement to it for grass, and that doesn't have tiling issues with it. So we try to find a grass that's maybe noise-based, somewhat procedural to use, and we'll be shipping versions of grass that people can use as well, so be on the lookout for stuff like that. Pay attention to things like glass. Make sure that you've overridden glass with good V-Ray glass. And metals, there are lots of really great metals that we ship with, again, that you can drag and drop and kind of go from there. Just to point out the global material overrides that I talked about earlier, anything that's opaque, we can use a pre-made material. I like to use diagrammatic materials, so things like museum board white, for instance. I would use, that would make the model white. Transparent, I would use like glass, or I can just do a standard transparent material that's just going to use a diffuse and reflection just like this, and that will allow me again to focus on my overall lighting, make sure my lighting is correct, make sure the camera is doing what I expect it to do. One thing to note, and I'll show you this here in just a little bit, is that you always want your vertical lines to appear vertical. And to do that in Revit, it's really important that you make sure that your camera and your camera target are aligned. And as long as those things are aligned, you should be in really good shape. It should do exactly what you would expect it to do. So in this particular case, I'm not going to render this. I can show you plenty of imagery that looks like this because I'd like to move on to the standalone material editor in the interest of time, and then show you some of the other effects that we can add to the scene to make things look good. So I'm going to just minimize that for a moment, and we'll kick over to the VRMat. And in the VRMat itself, this is our VRMat Editor. You can create new or you can open existing. We've got very basic settings here for diffuse color, reflection, refraction, index of refraction, right? So we've really tried to simplify this and make it as easy as possible. Our shader types are located here. And if you're not familiar with shaders, don't fret. The best way to learn about them is check on our documentation site. It's docs.chaosgroup.com, where we'll walk you through each of these. Or again, you can connect with your reseller, who will be happy to walk you through some of these as well. But we've got generics, we've got plastics, paints, glass, liquids, etc. That's all inside of here. Car paint, which has layers of information to it. Subsurface scattering too, which I talked about earlier, as well as this guy, emissive. And the nice thing to point out about emissive is that it actually casts light inside of your scene. So if we adjust the intensity or the color of the light, what you'll notice is that this starts to look like a light bulb itself or a light fixture itself. And there's some really great things you can do with emissive. Liquids like water, that's where bump is going to become important. Displacement can become important if you want it to look like an ocean, for instance, or if you want it to look like a bottle of wine. Those are all things that you can adjust in liquid. Finally, gemstones, which typically we don't show too much of. That's a very specific shader type inside of V-Ray itself and inside of V-Ray for Revit. So if you have something that's diamond or something of that nature, we have a specific way of showing that and adjusting the IOR as well as dispersion values so that you get something very realistic for a gem. For our purposes, you can drag and drop in the diffuse channel and the generic channel. You can drag and drop imagery into diffuse, and it will use that as a submap, so it will give you exactly what you need in that regard. So that's just a brief overview, and in the interest of time, again, we go through a lot of these things in detail in our documentation site, but knowing that they're there is important to creating an overall image that is the quality that you would expect. In addition to that, and I know that I'm not maximized in the view here, but just to show you this image, we're using a tool called aerial perspective here. An aerial perspective, as well as environment fog, you can find these things under settings. And if you go to fog, here's where you'll find aerial perspective and environment fog. And adding just a slight amount of aerial perspective or environment fog to your scene can add another level of realism to your overall scene. And actually, if we go back to this image for just a moment, we've got just a very slight amount of fog along the surface as aerial perspective. As you go back into the scene, you'll see kind of out here in the distance that we've got some level of fog happening there. And that's what you would expect in a winter scene. So when in doubt, use a photograph as a reference for what would happen in that particular image. Again, use model in white to start to really figure out what's happening with light inside of your scene. Here you can see we've done a section using the section box in Revit, but we can really study what's happening with light and form and our details here. And that allows us to get this kind of level of lighting. And here we're doing something, and I'll show you this in just a moment here, where we're using bloom and glare effects in the V-Ray frame buffer to get a softness to the overall light. So we're not doing much actually with interior lights here. We're getting a lot of the light from the exterior. We're again using HDR imagery as our background lighting source, pulling that light in and then using bloom and glare to add a softness to the overall scene. But materials really make the difference in making a scene feel real or not. And so let me just switch back to Revit here for just a moment, and I'll close this and this, and go back to full screen on this for just a moment and pull up in the frame buffer so I can show you where these tools are. And again, all of these tools that I'm showing you are available in greater detail on our docs.chaosgroup.com website. Or again, certainly you can check with your reseller here, and they're happy to walk you through this and work with you. We have individual correction controls over here. You've got kind of micro adjustment of exposure value even after you've rendered. So you do have the ability to adjust exposure and white balance here for more blue or more orange, as the case may be for white balance, depending on what your particular needs are. Same with hue and saturation. You can do lookup tables, so on and so forth, background imagery, etc. So that's all supported here under globals, and you can save these globals and apply them as well between images. In addition to that, you can look at white balance compensation, color balance, etc., color correction, exposure correction. You can turn all of this stuff on and off with these quick set buttons down here. Lookup tables, V-Ray history, so on and so forth. But the V-Ray lens effect settings, it's the last one in the list here. I'll show you, you can do bloom effects here, and we can turn this on, give it size and weight and intensity, and you will see that it will apply to the image as a post effect, so you start to see bloom happen there. And we can do the same with glare. We can add kind of a level of glare to the scene. So you add an overall softness to the scene, and I've really done it, an extreme example of this just to demonstrate some of what's happening here. But you do have the ability to do bloom masks by object IDs and material IDs, etc. Again, more of the advanced effects, so if you want to add bloom to specific objects, you do have the ability to do that. And you can turn on and off effects as you see fit. We talked a little bit earlier about individual settings and individual layers that you can export to Photoshop. So we can come in here and we can actually save alpha channel out, lens effect sources. We can send out RGB color, etc. But I want to show you where you can find more of those settings in channels here. So if you want to put output global illumination, lighting, reflection for my advanced folks who are familiar with exporting these layers, they are here and they are supported. You simply turn them on here, and when you render, they'll be available in that drop-down, so you can save them out as individual channels and composite them in Photoshop or your post-production software of choice. Self-illumination, specular, sample rate, etc. That's all here, background, your normals, etc. So we do have all of those channels built in, your diffuse channel as well, so you can do post-production compositing, as well as a denoiser channel. And for those who aren't familiar with denoiser, I'm just going to give you a bit of a topical, and then I'll wrap up here and open it up to question and answer. The denoiser allows us to take what would otherwise be noisy scenes that were rendered quickly and do a denoise pass over the top of that, which takes away some of that pixelization or noise that you would get in low light scenes specifically. But you can apply that by RGB or separate render elements that you can composite it. You can replace the actual RGB channel itself, and then of course we do support GPU processing of that, so if you've got a great graphics processor, you can use that. It's very, very fast, and it supports progressive updates as well, so you can add that in. It's just a fast way to get what would be an otherwise noisy image to look a lot cleaner in the end. And again, we go through the denoiser in some detail in our docs site. And we'll have quick start guides to each of these that are coming online. We've already got a few for external and internal lighting posted on our docs site, and we've got more coming soon. And of course, again, you can reach out and speak to the reseller, and I'm more than happy to work with you on these individual objects. And of course, we're happy to help as well.